Learn more, achieve more.
Okay, enthalpy of formation. First topic is enthalpy of formation. First, it is denoted with delta F subscript H. Okay, denoted with. And what are the equation you need to write? Suppose enthalpy of formation of acetic acid is given. Okay, suppose in the question enthalpy of formation of acetic acid is something like mentioned. Okay, so when it is mentioned like enthalpy of formation of acetic acid, then whatever the formation it is given, that need to be written on the right side, where it should be written on the right side. Acetic acid is CS3COH. Okay, and all products, all elements available in the product side, there should be, see, this is a formula only. There should be only one product and one mole product. This is the two condition. There should not be any other product in the formation. Okay, and there should be only one mole, and all reactant should be in the elementary state. How it should be? They should be in the elementary state. Okay, they should be in elementary state. Okay, okay, what we have to do to keep this one, we can keep this as a fraction. Okay, in enthalpy of formation, again I am repeating, whatever the enthalpy of formation, that is to be written on the right side in one mole. Only one product, one mole, and all reactant must be in elementary form. While balancing, there can be in fractions, they can be in fractions, like 3 plus 1 4. So here there is no problem, 2 oxygen, so already 2 oxygen. Suppose in some example there are 3 oxygen, there you can write 3 by 2, there is no problem. Instead of making it by multiplying and making this fraction, this coefficient as something, this can be kept in fraction to keep this as a 1 mole. Okay, so enthalpy of formation, is it understood? And what is, how it is denoted, how it is need to be converted into equation form. Is it understood, students? Now, when with the help of the enthalpy of formation, there is an advantage, use of information. Okay, use of information, use of enthalpy of formation information. Okay, first one is, it is used for comparing the stability. What is it is used? Comparing the stability. Okay, so suppose we are having two compounds, and the compound with more negative, the compound with more negative, the compound with more negative, the compound with more negative enthalpy of formation, more negative enthalpy of formation will be considered as more stable. Okay, stability more negative, value should be negative. If it is a product, enthalpy of formation is product, positive, means it is unstable. If enthalpy of formation is negative, stable. More negative, more stable. More positive, less stable or more unstable. Okay, second thing, reactivity. Okay, reactivity. So the product or the substance with positive enthalpy of formation is more reactive. Reactivity directly proportional to positive value. Okay, if negative is there, value should be less negative. More negative, more stability, reactivity. Understood? Then it is used in finding out the enthalpy of reaction, delta Rxn, enthalpy of reaction. Okay, these are the three uses. First topic, I think it is understood. Enthalpy of formation denoted with delta Fh acetic acid, like this equation, and these are the uses. Okay, then second topic, we are studying as a enthalpies, types of enthalpies. Okay, now coming to the enthalpy of combustion. Next topic is enthalpy of combustion. Okay, enthalpy of combustion. Okay, now in every topic what we will study, these are the common topics. Okay, what are the common topics? Enthalpy of combustion is denoted with delta Ch. Okay, delta Ch, it is denoted with, like there it was F, now it is C, enthalpy of combustion. Now In the previous topic, we have understood that it should be on the right side, but here it should be on the left side. Same example I am taking, enthalpy of combustion of acetic acid is given. Okay, then this, instead of writing on the right side in the formation, in the combustion, what you will do, you will write it on the left side. Where you will write it? You will write it on the left side, CH3 C double bond OH. Okay, and there you used to be only one product, but here there should be two reactant. You should make sure that there you should make sure that only one product. Here you should make sure that there should be two reactants, and the second reactant is always fixed as a oxygen, and there the substance which is formed should be, the substance which is formed should be 1 mole. Here the substance which is formed should be, which is undergoing combustion, should be 1 mole. To keep this 1 mole, you can do any damn thing on the right hand side. You can keep them in the fraction. Understood? So normally any hydrocarbon and its derivative, when undergoes oxidation, they will give CO2 and H2O. While balancing, you should not change this value. Okay? And two carbons are there, two CO2. Hydrogens are 4, so 4. Okay? And 4 plus 4, 8. Out of 8, already 2 are there, so 3 O2. Okay? So for that balancing purpose, you can do it afterwards. But three things you should remember. First thing, the substance which is undergoing should be written on the left side. Second, it should be associated with only another product, that is oxygen only. And third thing is, when it undergoes combustion, there should be 1 mole only. There should be how many moles? 1 mole. Okay. So these are the three things you should understand in the enthalpy of combustion, denoted with delta C. Okay. Now coming to the uses. Coming to the uses. Okay. So in the uses side, higher the delta C, enthalpy of combustion, then fuel characters are more. Okay. When the more negative, okay, when higher the enthalpy of combustion, better are the fuel properties. Okay, that is the first point. Second thing, all enthalpy of combustion are negative. Okay, always negative, except there is one exception, that is fluorine. Fluorine is more electronegative, therefore, for combustion, it requires energy rather than releasing. Okay. Third use is when enthalpy of combustion divided by molecular mass, then you are going to get calorific value. What you are going to get? You are going to calorific value. Is it understood? Second topic, enthalpy of combustion. Okay. Next is enthalpy of neutralization. Enthalpy of neutralization. Okay. So enthalpy of neutralization means when one equivalent of acid combines with one equivalent of base to form salt and water. To form salt and water is called as enthalpy of neutralization. Okay. And it is denoted with delta NuUNEUH. Okay. Enthalpy of neutralization. Okay. And here the uses I will tell you. First thing, it is used for comparing acidic or basic strengths. Comparing acidic or basic strength. Okay, first it is used in comparing acidic or basic strength. Let us take two acids are there, acid 1 and acid 2. Okay, then I will react both of them with same base. Okay, and let us take, this is delta H1, this is delta H2. Okay, suppose this is more negative, this is more negative, this is less negative. Okay, then this is more acid A1. Okay, A1 acid is more stronger than A2 acid. Okay, this is used to compare the acidic and basic strength. What it is used for? Comparing the acidic and basic strength. Understood? So here, for comparing acids, we will take base as a common. Same way for comparing the bases, we will take acid as a common. Is it understood, students? So this is first use. Okay. Second thing, it is used for degree of dissociation. To calculate degree of dissociation. What it is used? Degree of dissociation. Okay. In every reaction, there is one common thing. In every reaction, there is one common thing. What is that? Formation of water. Okay. So that's why enthalpy of neutralization is fixed. Okay. 13.7 or 57.1. Okay, what are the units? It is in calories, it is in joules. When both are strong acid and strong bases, then and when both are 1 equivalent, then this value is fixed. Suppose if something is less than this, that means it is undergoing less dissociation. So with that we can calculate degree of dissociation. Okay, because in the ionic equilibrium also I mentioned. Okay, suppose this is the acid and this is the base. Okay, so this is salt and this is water. Okay, now if this reaction is neutralization, this reaction neutralization. Okay, here I am telling it is always exothermic. Okay, what it is? Exothermic. So obviously in the ionic equilibrium we have studied backward direction is what? Salt hydrolysis. Okay, so salt hydrolysis will be what? Endothermic. Okay, so when the salt is NaCl, there I took example of in our previous lecture of ionic equilibrium. If not understood and not remembering, then you can see that video. Okay, so NaCl is a salt of strong acid and strong base. NaCl is a salt of strong acid and strong base. Therefore, it will not come back. That means there is no energy consumption because it is endothermic reaction. Suppose the same salt is made up of CH3COONA. Okay. Now it undergoes which type of hydrolysis? It undergoes anionic hydrolysis. Okay. CH3COONA, in the CH3COONA, CH3COO minus will undergo hydrolysis, because of which this reaction will come in backward. It is producing same amount in the forward direction, but in the backward direction it is consuming some amount of the energy produced in the forward direction. Okay, every acid and base will produce same amount in this direction, but whether if it is coming back or not, that will decide whether it is consuming or not. Okay, if it is coming back, that means it is weak. Okay, so that means what it will affect? It is going to affect about the enthalpy of neutralization. Okay, so enthalpy of neutralization decreases due to which reaction? Salt hydrolysis. Salt hydrolysis is possible when either acid or base or both are weak. Understood? That's with the help of the value. Suppose uh, actual value is 13.7. Okay, we have three acids. Okay, three acids A1, A2 and A3. Okay, and their enthalpy of neutralization, are it is 11.2, 12.7, 12.7 and 13. Okay, so which is having higher degree of dissociation? Which is having higher degree of dissociation? This is having higher degree of dissociation. Dissociation will be in this. Okay, so association will be in this direction. So acid A3 is having higher degree of dissociation and strong is the acid. Okay, is it understood? So with the help of the enthalpy of neutralization, we can compare the acidic and basic strength, and with this we can also calculate enthal degree of dissociation. Even dissociation constant also we can find out. Dissociation constant Ka is equal to P alpha square. Okay. So by the previous method I told you, we can calculate alpha. By substituting alpha here, we can find out Ka value. Okay. Like this, multi-concept formulas can be used. Thermodynamics topic of neutralization be linked up with the ionic equilibrium. Like that, link up questions are also possible. Okay, three enthalpies we have studied. They are the most important one. Okay, Now there are certain direct questions are also possible. Okay. Now fourth one is bond enthalpy. Okay. Bond enthalpy. Bond enthalpy. Okay. It can be positive or negative. How you take it, that depends. Understood? And it is denoted with delta BEH. Okay. So suppose there is a bond formation between A and B. In this direction, if you take, this is going to, in this direction it is going to be negative because bond formation is there. Okay. Amount of enthalpy change during formation of 1 mole of bonds, during formation of 1 mole of bond, okay, is called as bond enthalpy. At the same time, when you break that 1 mole of bond to give it to corresponding acids, so corresponding atoms, that time also same amount of energy required, here required, here released. That's why quantity wise both will be same, but sign will be opposite. Understood? So amount of energy required to break 1 mole of the one type of bonds, okay, or amount of energy released during the formation of 1 mole of one type of bonds. Understood? It is denoted with higher the bond enthalpy, higher will be the stability of the product formed, and less will be the reactivity of the product formed. Okay, like N2. N2 bond enthalpy will be high. That's why N2 is comparatively inert. Okay, like fluorine is reactive because bond enthalpy is less. Is it understood? So with the help of the bond enthalpy, first thing what we can find out, we can find out their reactivity. Okay, we can find out the bond enthalpy. We can find out what are the two things. First thing is we can find out the reactivity. What we can find out? We can find out the reactivity. Compare the reactivity. We can compare the stability. Okay, we can compare the stability. And third thing, we can find out the enthalpy of reaction also. Okay, how we are going to do that, I will explain when we are studying the types of enthalpy. There is a topic enthalpy of reaction. Okay. So there is a request from our one of the student that sir can once again define a bond enthalpy. Understood? So that is the advantage of being in class. Whenever you are feeling problem in some place, you can ask, clear your doubt then and there. Understood? Okay, see here bond enthalpy can be defined in two different ways. Amount of enthalpy released or amount of heat released when 1 mole of bond formed. Here there was no bond, there was no bond, but they are creating a bond. Okay, so whenever bond formation is there, energy will be released. That amount of energy released is called as bond enthalpy. And when you break that molecule into atoms, that is possible when you break that 1 mole of bond again. Okay, so once this side it is released, this side it will be required. This side what it will be required. Okay, so same amount only. That's why this is called as a bond enthalpy. Bond enthalpy can be defined in both ways, but one word should be replaced. Here when you talk in this direction, released. When you talk in this direction, required. Okay, amount of bond energy required to break 1 mole of bonds or amount of energy released during formation of 1 mole of bonds. Okay, so with the bond enthalpy, we can find out reactivity, we can compare the stability, we can find out enthalpy of reaction. Okay, next, fifth one is bond, so otherwise enthalpy of reaction. Okay, enthalpy of reaction. This word I have used two times in the same lecture. Okay, in the same lecture. So if you are not understanding, you can go back afterwards and revise it once again. Enthalpy of reaction, I took this word in two places. One is during the bond enthalpy and during enthalpy of formation also. Okay, suppose enthalpy of reaction. Okay, enthalpy of reaction is amount of enthalpy change, amount of enthalpy change when all reactant are taken as per the quantities mentioned in the balanced chemical equation. balanced chemical equation. Suppose if I am talking about the enthalpy of reaction, it is denoted with the delta Rx and H reaction. Okay. So if I say enthalpy of reaction of this is some suppose minus 353, let us take. Okay. So that means when I take 28 grams of nitrogen and allow it to react with 6 grams of hydrogen, which resulted in formation of 34 grams of ammonia. During that reaction, this much energy released. Minus says that released, this much energy released when I make it this reaction possible. Okay. So amount of heat change during reaction carried out by taking quantities as per the balanced chemical equation. Understood? So enthalpy of reaction can be negative, positive, anything. Understood? So if it is more negative, that means reaction is spontaneous. Reaction will be spontaneous. Okay. Reaction is what? Spontaneous. It will undergo in the forward direction only on its own. Okay. Suppose it is positive. That means we should give this much amount of energy, then only it is going to react. That is non-spontaneous. If something occurs on its own, then it is called as spontaneous. If somebody has to give external energy, then it is called non-spontaneous. Here, this much energy is needed to be added along with the reactant. Okay, but if it is like this, okay, then it shows that it is a spontaneous reaction. It not only gives you product, it also gives you energy. That much spontaneity can be explained. Okay, enthalpy of reaction, is it understood? Now I take back to the previous topics where told you that enthalpy of formation can be used in finding out enthalpy of reaction. Okay, so for this, suppose enthalpy of reaction. Enthalpy of reaction is equal to enthalpy of formation of products. Okay, all product must be written minus enthalpy of formation of reactants. Okay, here product it is. One more thing is enthalpy of formation is only for 1 mole, but here we are forming 2 moles. So 2 into ammonia here. Okay, minus 2 reactants are there, both values you should write along with the coefficients. Okay, so this is the formula relation between enthalpy of reaction and enthalpy of formation. Okay, then coming to the bond enthalpy, this is most and most important. Everybody does mistake. Okay, what is that? Enthalpy of reaction when it is explained in terms of the bond enthalpy. Every time, every place you will write product minus reactant, but this is the only place you have to write reactant minus product. What you will do? Reactant minus product. Okay, so bond enthalpy. Okay, bond enthalpy delta BE of reactant. Okay, minus delta bond enthalpy of product. Is it understood, students? Okay, now this is about the enthalpy of reaction in terms of the reactant. Okay, so I will explain this with the same example. Okay, but in detail. Reaction is same, but depending on the information you have to modify your formula. Okay, one example I am taking. Okay, this 2 moles of NH3. Understood? Now, during this reaction, if formation is given, then Rxn, enthalpy of reaction, is equal to 2 into enthalpy of formation, of NH3, okay, minus 1 into, okay, enthalpy of formation of N2. Is it understood? Enthalpy of formation of N2, okay, mine plus 3 into enthalpy of formation of H2. Okay, so this is how you will understand product minus reactant. Okay, but the same question, same reaction, if they give through the bonds. Okay, then what you will do? You will write the bonds clearly. N2 plus 3 into H bond H gives 2 into N single bond H. Understood? So now it is you need to write in a bond form. Okay. Here enthalpy of reaction only we are going to study. Okay. So but the way of writing the formula, the way of writing is different now. Okay. So this enthalpy of reaction. Okay, enthalpy of the same reaction is equal to reactant minus product I told you. Okay, first one is bond enthalpy, bond enthalpy of N triple bond N. And how many bonds are there? Only one bond. Don't look here three. It is not equal to three single bond. It is equal to one triple bond. Understood? Plus 3 moles of, okay, 3 bond enthalpies. Okay, 3 bond enthalpies of hydrogen single bond hydrogen. Okay, hydrogen single bond hydrogen. Is it understood, students? Now, this reactant, all bonds I mentioned. Here, triple bond is there, I mentioned. Single bond is there, I mentioned. 3 moles are there, 3 I mentioned. Okay. Then minus product. Here, product, there is only one product and they contain only one type of bond. What is that bond? Bond enthalpy of N single bond H. Okay, but how many? One, two, three. In one molecule, listen carefully. In one molecule, three bonds are there, and like that, two molecules are there. So, total how many bonds will be there? Six bonds. Okay, one molecule, three bonds, and two molecules are there. So, how I got six? Is it understood now? This six. How I got it six? Any doubt about this? Okay, this is how the enthalpy of reaction is. Is it understood, students? Okay, bye.